As I've stated before, SpectraCyber is basically a tool set. Depends on how you take your data and what your data will look like when you finally get it all saved in your temp.csv file or your project file. Now there's a special case where if you're doing spectral scans and you're using a timer, what's going to happen is that the data file will be a sequence of bandwidth sweeps across the chosen bandwidth frequency that you've set up in the commander, and there'll be one after another. Now if you're doing meridian scans, this means that each one of those scans will be at a different right ascension as the Earth rotates through your meridian. So the data can look a little bit convoluted at times if you plot it. We're going to take a look at some of this kind of data and try to understand how to use it. Basically, you will find that all your data will be in a textual CSV file. You can then load that into a spreadsheet program, and you can cut out any portion of that data that you wish to use for that particular right ascension group. So let's go ahead and take a look now at some data that I previously recorded. Okay, I've already set this up so that we can see this data. I previously took some data where I did multiple scans across a region of the Cassiopeia's galaxy. Now you'll notice if you look at figure number 1, and I've plotted this data as voltage versus the shift frequency, the data is being overlapped. Multiple frequencies are being rescanned over and over, and so the data looks a little very convoluted. It's not easy to see a good reading on this. However, if you look at the figure 2 is now being plotted as volts versus right ascension. So each one of these frequency scans are shown as a series of peaks. All of this data has been joined together in a single CSV file, where you'll be able to see over on the page at the table at the left here, you can see that we begin to sweep at certain frequencies. Let me scan this up, pull this up to the top, and we'll see what it is. Here you notice that we start off at minus 175 on the frequency column, and as we scroll this downward, you'll notice, get this to move here, there it is. You see the different frequencies as we scan down. The further down I come with it, you'll see that we're onto the positive side, and if I continue to come down, we're back into the negative again on the second peak, and so on. So each one of these scans is joined together in a file that is sequenced together. So if you were looking at a particular area, you'd want to see at what right ascension where that scan is. You can then go into the CSV file, find that same location, and you can cut and paste out that region and do whatever you need to do with your mathematics on that one. This is why I said earlier that when you were doing scans, spectral scans that were timed, you would have all this data joined together. That's why we use the scan timer that we looked at earlier in an earlier session, so that you could pick out which one of those frequencies groups in the middle would be important. For example, the 4.5 would be the fourth peak here, someplace around just after 11.45 right ascension. So that is really what happens. You should really look at your data, take whatever analysis you want, take a look at how that data is stored in the CSV file, and then use whatever part of that data is useful for your particular study or experiment. So I hope you understand now that how to use the data sets that come out of the SpectracyberRPi software.